All right, testing, testing. Okay, cool. All right, hello guys. Today I am going to talk about the different flavors of accelerating a transaction. So first off, who here has heard about RBF? All right. Who here has heard about CPFP? And who here has heard about P2A? Okay, cool. Significantly less every time. Well, first off, this is going to be an interactive presentation. So if you do have your laptop, feel free to pull it out. The code I'm going to be using is right here. It probably will have some errors, but I still highly recommend that you guys follow along. Okay, so I'm going to go over the 3 different flavors of acceleration, how they work, and sort of what the specs are behind each one. Huh? Oh, all right, you guys are still cool. We'll give everyone a couple seconds. And this is assuming you have Bitcoin Core installed already on your computer. If you don't, ask a neighbor. Okay, I'm going to move forward now. This clock's not working, so all right, I'm just going to kind of guesstimate time here. Cool. So like I said, we're going to go over RBF, CPFP, and P2A, and we're going to go over sort of what are the differences between each one, how do you use each one, and where is the right use case for each one. Cool. So obviously, what is accelerating? Well, transactions get stuck. If you don't have high enough fees for the transactions to get mined, transactions can get stuck in the mempool for probably longer than you'd like. So how exactly do you get one of these transactions through to miners? And the first one that everyone's kind of aware of and is probably used is RBF, which is replaced by fee. And this is, again, the one that is most popular. If you go to mempool, the accelerate button allows you to do this. And all this does is it replaces an unconfirmed transaction with a new version that simply includes a higher fee. So same transaction, same inputs, same outputs, just with a higher fee to incentivize miners to include it in the block. This had been discussed many years along the community, but it only recently gained widespread popularity from ordinals and inscriptions. So there's some testament to, ordinals and inscriptions are definitely pushing innovation along in core. Heard a hell yeah in the crowd. Okay, so what is the spec? Well, so there's opt-in RBF, which came in BIP 125. And this is actually signaled in the transaction itself in the sequence field. So if you guys look right here, this is how it's typically signaled. And this is how you conveyed that your transaction that you are broadcasting, you are OK with it being RBF'd. Now, that is opt-in, and that was the first version of it. Now we're kind of seeing full RBF, where nodes can enable full RBF with this policy here to the right. So mempool full RBF equals 1 parameter. This means that even if your transaction doesn't have the sequence field signaling, you could probably still RBF it. There is no guarantee. It kind of boils down to the network composition and how the nodes behave. Okay, cool. So RBF demo. So now the people that are following along, I'm going to go ahead and try doing it live. Here we go. Here we go. Okay. Can I increase the size? No. Or I can? Yeah. Okay, all right, we're good. Okay, cool. So going to go ahead, start reg tests, and then on the other side, we are going to run cargo run to actually start the demo. So let me increase the size here as well. And actually, technically, only this guy matters. All right. So first, select the demonstration. Again, we're going to do number 1, replace by fee. OK, cool. And you guys are seeing a bunch of print statements. Ignore the emojis. I kind of asked Claude to help make this presentation more interactive. And it just shoved probably too many emojis in here. But you guys follow along. What we're doing is we're first creating a transaction with this UTXO. And we're broadcasting it with fairly low fees and with RBF enabled. So if you go ahead and press enter, we're going to create a replacement transaction which uses the same UTXO, so BF55D, BF55D, except now with a 10 times higher fee. And if we go ahead and press enter again, we will see that that second transaction will be confirmed. Cool. So again, this was fairly straightforward example. You have one transaction broadcasted, low fees. You recreate the same transaction, much higher fees. You push it through. And again, this is probably the flavor of acceleration that most people are already familiar with. All right, so next is CPFP, which stands for Child Pays for Parent. And in this one, you have a transaction that is broadcasted, a parent with low fees, and it's not necessarily mined. And so what you do is you actually spend that transaction with a new transaction called, referred to as a child, with significantly higher fees. And as you can see by the little chain over there, both miners take both of the transactions together as a package and pushes them through. What's interesting about CPFP is this was technically always feasible, as there's no strict signaling required. So there was no BIP, there is no like transaction formatting, node policy that's required here. It's just good old economic incentive. If miners see that the package of these two transactions, is profitable for them to mine, they're going to go ahead and implement, and they're going to go ahead and mine the transactions. So going back to the demo, we're going to do, and again, this is definitely not great code, because if it were, you'd be running it from the same instance every time. So press cargo run again, we'll press number 2, and now we're doing exactly what we'd expect on this example, where we create a parent transaction with a very low fee. We're disabling RBF for this example. And we can see that it's in the mempool. And now we're going to go ahead and create a child transaction that spends one of the outputs from that first transaction. And we can see, OK, cool. As we can see at the end, it is both the transactions are successfully mined together as a package. And so again, this shows one parent transaction not being mined. We have another child one, spends that first one, and they're both included by the miner because, again, it's now profitable for them to mine. And the last flavor of accelerating, which is definitely the newest and the one that people have heard about the least, is P2A, pay to anchor, or another name for it that you might have heard is ephemeral anchors as well. And this actually comes from 2 different updates. One is a new version of transactions, V3, also known as truck transactions, which are named that because they're topologically restricted until confirmation. And these are described, big words here. These are described in BIP 431. And in order to comply to this standard, they need to have 4 different items. So you can see there, 1, V3 can have a most 1 unconfirmed parent. V3 can have a most 1 unconfirmed child. If you're attempting to spend it as a child, that also must be a V3. And child transactions are also limited in size. And so pay to anchor is actually made up of 2 different features. So we have 1, truck transactions, and 2, ephemeral dust. So ephemeral dust allows you to have 1 single output per transaction that has 0 value in it. And so if you try doing this with any other type of transaction, transaction 1 or transaction 2, or if you try having more than 1 output that has 0 in the value, they will fail. And so this is specifically unlocked by truck transactions. And this is technically what's referred to as the anchor, right? So 1 single output, value of 0, and they always have the same pub key, which you can see right here. So 0x51, 02, 4e73. The 0x51 is SegWit version 1, 02 because we're about to push 2 bytes, 4e73. And it always gives you this little pub key to the right. So BC1 fees raw GF. And so if you look up this address on a mempool explorer, you'll see any time that one of these anchors was actually used on chain. And again, the point of using pay to anchor is the fact that anyone can accelerate a transaction now. So in the previous example that we had, it was only, you could only spend that as a child if you were one of the recipients of that original transaction. And in our very first example of RBF, only if you were the original, the signer or the original person creating that transaction could you spend it. But the coolest feature about P2A is that anyone can come along and accelerate these transactions, which unlocks a lot of fairly cool features. So now we're going to go ahead and run this last example. Okay, cool. So we're creating one transaction. Again, very low fees. We are including our P2A script, which again, as we see here, 51024E73. Again, op1 for the SegWit version. 02 is missing here, but it stands for because for the amount of data that we're about to push to the stack, which is 2 more bytes, 4 bytes total. We can see that we broadcast this with fairly low fees, and again, a value of 0. And so we're crafting the child transaction. And now miners see that there's a high transaction for including both of these transactions in. They both end up being mined together. And so really cool way of, again, accelerating any transaction without being either the person that receives it or without being the original person that crafted the transaction. And so for a nice little compare and contrast at the end, RBF, CPFP, P2A, when were they activated? RBF was technically activated in BIP 125 around 2016. CPFP has been theoretically feasible since inception in 2009. And P2A is still experimental as of 2024. Who can accelerate? Again, this is what I would say is probably the biggest difference between these 3 methods. RBF, only the original signer can accelerate it. CPFP, and again, if this is a multi-sig, this becomes a nightmare because you need to send a transaction again, get it signed by everyone in the federation, etc. CPFP, only the people that are recipients of the outputs can accelerate it. But P2A, anyone can accelerate these transactions. And again, network support for the first 2 is universal, while the last one is still sort of limited as it is experimental as of now. So again, which one do you want to choose? Totally depends on what you're trying to do with your transaction, whether you control inputs, outputs, etc. And yeah, I really look forward to seeing people use P2A. I know that we're personally using it in a bridge project of ours that we're fairly excited to have it working. And yeah, I'm done here. So I'm going to go ahead and open the floor to if and any questions.
Testing? OK. So the P2A on the last slide, who can accelerate anybody? The problem with it is binding support or getting it relayed around the network.
Right.
And so just like my anecdotal evidence here is that basically around 80% of the hash rate has upgraded to version 28 or higher, which supports base pay to anchor. So it shouldn't be any problem to really get these mined or relayed right now. And
cool.
that's been happening since about basically like November of last year. So
awesome. Yeah. So
it's
that's
pretty,
November 2024.
basically what I'm saying is it's pretty safe to. And then the other note about pay to anchor, I think it's pretty cool, is like it supports technically like any transaction. You literally just have to include this one out point.
There's one output.
And then you're basically anybody at that point can boost your transaction, even if it's like maybe an accelerator service like mempool.space or something offers like, hey, we'll add an output to your P2A. And yeah, it's like anybody can participate.
Exactly.
So it's really cool.
Josh?
So regarding P2A, it does mean, if I'm correct, if I believe right, like that you have to include the P2A output in your first transaction.
Yep.
So no matter what, under standardness rules, there has to be a second transaction that spends from it.
Right.
So that would mean that if you don't want to accelerate it, or if you don't need it to, if you didn't need to accelerate, now you're paying more than you would otherwise have needed to pay. Is that right? I think.
Can I answer?
Yeah, sure.
Okay. Sorry, very excited. So just adding the pay to anchor, so the output, the 0x51 2 byte push and then 2 bytes, that is just part of its standard now. So as long as you pay an above dust fee rate and a relay rate that's acceptable, you can do a single. It's only when you want to do that truck combination to get the sub relay rate transaction in, do you have to pair it with the spend of that.
So if you committed to a dust output, you're kind of screwed if fee rates go way down and now you don't need to.
Yes.
It's like, you're not screwed, but.
You still have to pay full dust off that. 300.
Hey, I want to ask some 101 questions for
Shoot.
for RBF. I mean, unless you are looking at mempool space or you know it's been RBF. Is there any sort of footprint to know a transaction has been RBF? Versus, I know like with CPFP and pay to anchor, there's going to be some sort of on-chain footprint to let someone know like, oh, this was a CPFP. But is there any for RBF, or is that going to be
That's a
just
good question.
a mempool only thing?
Yeah, I don't know at the moment. I would only be able to tell from mempool.
Okay, and one more quick follow-up. So right here you have anyone can accelerate a P2A. And this might be my lack of understanding, I was under the impression that CPFP is also sort of a anyone can accelerate. I mean, because ultimately you can, just you.
Spend one of the outputs.
You have to be able to spend one of the outputs.
Okay, I guess I'm thinking with coordination of the person in need
Sure.
with CPFP. So I guess
Sure.
you don't need to know them with pay to anchor. Okay.
Right. Exactly.
Yeah, so one of the places where this is really useful is if you think about like lightning channels. On, each person's end of the lightning channel, what you normally do is like you have a little anchor output, and then either person can accelerate the closure of it. But if you have an ephemeral anchor or a P2A output, then you have one output that either of them can accelerate. So instead of needing like Alice and Bob to each have their own output, you can just have a single shared output.
Yeah.
It's like pretty cool.
I think Portland's trying. Someone over here.
Sorry, Portland.
I'm curious about the landscape of people using P2A right now. Are there any accelerators where maybe I can add a band, pay them over Lightning because I only have Lightning sats left, and then they'll...
Yeah, it's still early enough, but I think there's a business waiting to be built there. Yeah.
Are people what are people using P2A today for? And you mentioned you had a project.
I know, for example, that there is a bridge that is being built that is including P2A as well, so that if the signers can't accelerate the transaction, then the person who's waiting for the bridge to come through can go ahead and do it anyways. Portland, your last one?
So pay to anchor is pretty cool. I really like truck pay to anchor a lot. And at Mara, you mentioned the limit of the parent is 10 kilobytes.
Okay.
So it's not very useful for meta protocols in some cases, but I'm hoping deep down somebody eventually does a big zero fee transaction, attaches an anchor, and maybe their community can help pay for that transaction to exist in the reality, make it onto the time chain. So,
Cool.
But
So-
Mara is not limited to 10
To the
kilobyte.
10K.
Everybody else is though,
Okay.
that I know of.
Copy.
The parent, the first one. No, there's a setting for the total size of the parent you can set, and yeah, I think I'm right here, but I could be wrong.
Cool. Any other questions? All right. Thank you for your time, guys.